Okay, so shall we wait for another 2-3 minutes because only 12 have got submitted. Is it audible? Is it audible, friends? Is it audible? Okay, so I think we have discussed the planes problem. So today one more different problem, we'll just go through it and we'll close this module today. Okay, so we'll take this an example. Problem number 22. This is something we call it as a complementary angle problem. So what is it being given in the problem? We'll just go through it. A pentagonal lamina of size 25 mm is resting on one of its edges on HP with corner opposite to that edge is touching VP. This edge is parallel to VP and the other corner which touches VP is at a height of 15 mm above HP. Draw the projections of the lamina and determine the inclination of the lamina with HP and VP, the distance at which the parallel edge lies from VP. Okay, so in this, what is it being given in the problem is, it's a pentagonal lamina of one of its side is 25 mm and is resting on one of its edges on HP with the corner opposite to that edge is touching the VP. So this corner which is touching the VP, can you just see here? That is also given. The last position of the problem is also given. This edge is parallel to VP. This edge is parallel to VP. And the corner which touches VP is at a height of 15 mm above HP. So rather than giving an angle, they have given 15 mm above HP. It is given. The corner which touches VP is at a height of 15 mm above HP is given. Draw the projection of the lamina and determine the inclination of the lamina with HP and VP. We are supposed to find it. The distance at which the parallel edge lies from VP is also we are supposed to measure. So what is it being given in the problem is that it is resting on one of its edges in such a way that this corner is touching the VP. And also the edge is parallel to VP. The edge is parallel to VP. So in that case, we place the pentagonal lamina in HP, and of course we'll with a side of 25 mm, we'll get the front view that is seems to be like a line. That is the surface of the lamina we'll get in the front view. This line is nothing but it is the surface of this lamina. This line, 1 second, sorry. So this A dash, E dash, B dash and D dash, C dash is a surface of the pentagonal lamina, but it looks like a line in the front view. Similarly, while doing it in the second position, it is said that the corner opposite to that edge, it is touching VP, is 15 mm above HP it is given. So for that, we can use this data for positioning of the surface in the front view. So that is why 15 mm line you draw, a locus line of 15 mm above HP, and anywhere this C dash you just place it here. This you can measure in the compass. Placing C dash in this locus line, cut an arc on the XY line so that you will get this edge. The second position edge you will get. Using the horizontal and vertical construction line, locate all the points and you can connect them with a thick line. You will get the apparent view of the top view. Apparent view of the top view will get. This one you will get. But for the third position is concerned, either with respect to VP or HP, they have not given the inclination here. The angle which is not, which is unknown. But what is being said is the corner which is opposite to the edge, which is touching the vertical plane. So this is my vertical plane, right? So this is my vertical plane. So that is the corner C is touching the vertical plane. So in order to place this lamina here in such a way that the C can meet at XY line anywhere in the XY line. So again, for this also we'll follow a box approach method by locating 1, 2, 3, 4 of with 1, 2, 3, 4 and everything to be bring it in the box, and using the same procedure we'll just place it the lamina here. But only thing is the C is supposed to be meeting vertical plane, that is XY line. So once you do that, using the horizontal construction line, you can locate all the points wherever it is meeting. For example, starts from A always. A is resting on XY only. A dash is over B dash. Similarly, C dash, D dash, and connect them with a thick line. So it will be your final position with respect to front view. So similarly, there are around some problem it is given. A pentagonal, we'll just see problem number 25. A pentagonal lamina of sides 25 mm is having a side both on HP and VP. The surface of the lamina is inclined at an angle of 60° with HP. Draw the top and front view of the lamina. So a pentagonal lamina, again it is 25 mm is given, is having a side both on HP and VP. The surface of the lamina is inclined at an angle of 60° with respect to HP. Maybe this problem is, I'll re-look into this problem. Maybe throughout this primer book, there are some errors in data is there. I think that I have shared with your class, the correction which is supposed to be required in the V2 primer book. So here you just look at the problem number 26. A regular pentagonal lamina of 25 mm side is resting on one of its corner on HP, while the side opposite to that corner touches the VP. So this is the side opposite to that corner is resting, is touching the VP. Touching the VP in the sense it is touching XY line. And with respect to HP, they have given the angle 60° with respect to HP and 30° with VP. Okay. Here, friends, these are we called as a complementary angle problem. So, how do you identify complementary angle problem? For example, they will give you in two ways you can identify the that it is a complementary angle problem. So, for example, in this problem, you will get confused. I'll just go through it this problem once again. Just look at here. A regular pentagonal lamina 25 mm side is resting on one of its corner on HP, that is A, while the side opposite to the corner touches VP. If the lamina makes an angles of 60° with HP and 30° with VP, draw the projections of the lamina. So this sentence is very, very careful. So anywhere in the problem, with respect to HP and with respect to VP, if you sum the angle, if it is equal to 90° angle, you need not to draw the 30° line and do it. Straight away we go for 90° and then we'll do it. Hope it is clear. This is one way of identifying the problem under complementary angle. So that's why we that's why we say it's a complementary angle, because if you with respect to HP and with respect to VP, if you add them 60 degree and 30 degree, how much it will be? 90 degree. If it is a 90 degree, then it is a problem under complementary angle. So complementary angle up to second position, it will be same. In the third angle, rather than taking a 30-degree line as per given in the problem, directly straight away we'll position it in such a way that the edge, the edge opposite to the corner is resting on VP or touching VP, sorry. So that is what also, this is one way. And second way, it is very clearly given the opposite, while the side opposite to this corner touches VP. So two sentence, one is with respect to angle, you can say. The second one, they will give either the corner is touching VP, or the side opposite to the corner is touching VP. So like that they will give. If it is given such sentence, if you find such sentence in your problem, then straight away you can go and solve using complementary angle method. Complementary angle method. So how do you do this? It is very simple. You need not to draw any angle with respect to VP or HP in the final position. Straight away we'll just place it. For example, here DC will place it in such a way that it touches VP, that is XY line, and then we'll solve it. The further remains, the procedure remains same. We'll look into some other types of also problem of similar kind, and then you will get you'll get a fair idea. So we here problem number 28. A regular pentagonal lamina of 25 mm side is resting on one of its sides on HP, while the corner opposite to the side touches VP. See here. The corner opposite to the side is touches VP. This is one hint. What we can, using this, you can be able to judge that it is a complementary angle problem. In the second, if the lamina makes an angle of 60 degree with HP and 30 degree with VP, if you add 60 and 30, again it is 90 degree. So it's a complementary angle problem only. Even though if you make it inclination and everything, the finally you will get the same thing. So that is why rather than going for an angle, we directly place the lamina in the final position in such a way that the corner or the side, according to the data it is going to be given in the problem, we'll place it. So here up to here it is everything given. To get the final position, this C will place it on XY line. Same thing, just as like previous one. So here also just look into it. This all I think we have seen. Problem number 33. Draw the top and front views of the hexagonal lamina of 30 mm sides having two of its edges parallel to both vertical and horizontal plane, and one of its edges is 10 mm from each of the plane of projection. The surface of the lamina is inclined at an angle of 60 degree with respect to HP. So what is it being given? The two sides of the hexagonal lamina is parallel to both HP and VP. Just see here. Having two of its edges parallel to both vertical and horizontal plane. So here, problem number, sorry, 1 second, just give me a second. So here, what is it given with respect to HP given? With respect to vertical plane, the data is missing. The data is not missing. They're given that the two sides of the hexagonal lamina is making parallel to both VP and HP is given. So with 30 mm line, we can place the hexagonal, and in the front view, we will get the surface of the lamina. It looks like a line. With respect to HP, we'll do that. But in all the cases, what they have given, vertical and horizontal on one of its edges is 10 mm from each of the plane of projection. It is given. Each of the from plane of projection from the reference plane, always it is 10 mm distance. So here the front view will not place it on XY line, rather will place it by taking 10 mm line from plane of reference, 10 mm, and then we'll do it. Similarly, every plane, every lamina in with respect to any position, it is 10 mm from the plane. So that is very clear. So what you do is 10 mm anywhere you can place it here, but here also you measure 10 mm from XY line and then give the position to the lamina hexagonal. After that, front view. After that, you tilt it with respect to 60°. You will get the top view that is very foreshortened. That is apparent view of the top view you will get compared to first one. So similarly, you place it in such a way that this A and F, the second apparent lamina, that is this lamina, you rotate in such a way that A and F makes parallel to vertical plane. So we will be tilted in such a way that we will tilt it in clockwise direction, so that it will be given like that. And similarly, you will get the final position. So how do you tilt it is very, very important. Sometimes they will say opposite to the edge on which it is resting, then you have to tilt it. D and C should come above. A and F should come below. So all this comes under complementary angle problem, we call it as. So here you just look at this problem number 36. Problem number 36. A regular hexagonal lamina of sides 25 mm is lying in such a way that one of its sides on HP, while the side opposite to the side on which rest is on VP. If the lamina makes 60° to HP, draw the projections of the lamina. So what is it being given in this problem? It's quite interesting. You just look at here. A regular hexagonal lamina is given of size 25 mm. Using this, I think we can be able to do that. It is placed in such a way that it is placed on one of its sides on HP, while the side opposite to that side on which it rests is on VP. So what I could notice from this is, and if the lamina is 60 to HP, draw the projections of the lamina. So what they are saying is, so what they have given is, this is the edge opposite to the edge on which it is resting. For example, according to this problem, the edge on which it is resting is AF. The opposite edge to this is DC. So one edge is resting on HP. The other edge is resting on VP. So that is what given. So up to here, we can be able to do it. But here, you have to, for example, this is the apparent view. Apparent view of the top view, we can get this. But here, when placing it, what you should observe, whether you should place it in the third position by rotating either in clockwise or anti-clockwise is major is completely matters. So if you, for example, if you tilt it in the clockwise direction and place it, the problem will be wrong in this. Why? Because the opposite edge, that is DC, is the opposite edge is resting on VP. So in anti-clockwise, you have to place it here in such a way that the D and C should touch this XY line. should not A and F, because it is very clearly given. The edge opposite to the edge on which it is resting is touching VP. It is given. So D and C should be touch the XY line. So that, and if you touch only D and C, then only your F and A, because already the F and A should, it is touching HP. FA and F and A is touching already HP. So only the option is left to you now. D and C should be touch on VP. This also you should be very carefully see it. So with this, I think more or less, I think we've done this. So what I'll just do is, I will now, I will unmute all of you. So we'll have one by one interaction, so that any doubts if you have, you can straight away you can ask me. And with regards to assignment, I'll identify a few assignment problem, and then I'll give it to you in the WhatsApp. I'll message you. But before that, before we close this module, I just wanted to discuss with you, if you're finding any difficulties and all that, please let me know. I'll just unmuting all, and one by one, you please stop. Maybe we can go for another 5 to 10 minutes, and we'll do it. I'll be unmute all. Yes, friends. Yes, anyone? Who is this? Yes, anyone can speak. Shall I close this otherwise? Are you people there? Okay, fine then. We'll close this. Thank you. अब जब आपको भी ऐसा लग रहा होगा कि आप